So continuing on here with 8.3, the number e, we're still graphing. We're on example 3. So let's take a look here at example 3. When we go to graph, go to y equals and clear all that out. Now it starts with e. So what I want you to do is I want you to do second and ln. That gives you your e. And basically what we have is a negative zero point 0.5. So put negative zero point 0.5. Then we need another parentheses because we have that parentheses up here. Then put the x minus 2, then end parentheses, but because we have two parentheses facing to the left, we need to have two parentheses facing to the right, which means you have another parentheses. So far you should have written down e caret sign parentheses negative zero point 0.5 parentheses x minus 2 end parentheses end parentheses is what you should have. Then don't forget to put the plus 1 there and go to graph. Notice how the graph is going down now. So the graph is going down from left to right. So when we go to our table, second graph, let's go find negative 2. And when we plug in a negative 2, we end up with 8.39. When we plug in a negative 1, we end up with 5.48. When we plug in a 0, we end up with 3.72. When we plug in a 1, we end up with 2.64. When we plug in a 2, we end up with 2. So when we go to plot these, negative 2, 8.36 is roughly here. Negative 1, 1, 2, 3, 4, 5.48 is roughly there. And when we plug in a 0, 1, 2, 3.72 is about there. We plug in a 1 and 2.64, it's about there. And 2, 2 is right here. And we draw our line. Okay, so there's the graph. This should actually be going down a little lower, but the point is the asymptote for this is actually going to be 1 at y equals 1 because this number right here is what the asymptote is. So at the line y equals 1, that means this graph is going to keep going until it gets down to 1, and you can check your list. Notice how the numbers keep approaching 1 and they keep getting really, really close. And then it's saying on your calculator at 22 it's 1, at 23 it's 1, at 24 it's 1, at 25 it's 1, at 26 it's 1. The reason why they're doing that is they can't really keep going out any farther. They can't say 1.0000000000001 because it won't fit on your calculator. So they're just approximating that it's 1. It doesn't mean it actually touches 1. So the point is the horizontal asymptote is 1 for this problem and it just approaches it. So continuously compounded interest. We were talking about compound interest before, but now you're going to use this formula whenever the problem is talking about continuous, as in every second, every minute of every day interest is accumulating. You will use this formula right here. P is still the same as it was, right? P is still the same as it was. E is not a variable. E is the number 2.71 that we were talking about. R still stands for rate and T still stands for time for hours. So the continuously compounded interest formula, I like to call it PERT. Okay, so P is still the principal amount of money that you put in. R is the rate, and keep in mind the rate you have to write as a decimal. Even though it'll show up as a percent in the problem, you need to write it as a decimal. And T is still time, and that needs to be in years. So, you deposit $1,000 into account that pays 8% annual interest compounded continuously. What's the balance? The key word here is compounded continuously. Since it says continuously, I know I'm using this formula. If it said compounded monthly, I wouldn't use this formula anymore. Okay? Because it's compounded continuously, I need to use this formula. That's how I know I'm using this one. But if it said compounded annually, compounded monthly, compounded quarterly, that's when I know that I'm using the other formula, the other compound interest formula that we talked about in 8.1. In this one, since it says continuously, I'm using PERT. So the amount of money put in was 1,000, so I put 1,000 in for P. The rate is 8%, so I put in a 0.08 for R. And we want to figure out what T is, and it says what's the balance after annual interest. So they just want a year, as in 1. So since it's annual, they just want to know what happens after the first year. So first year meaning 1 goes in there. So literally on your calculator, you can type in 1,000 times, go to second ln, that will bring up the E, and then type in 0.08 times 1 in parentheses, you get 1083.29 as your answer, which means after 1 year you gained $83.29 if it was compounded continuously. So there's your homework. Finish that up for tonight. You're going to have some graphing. You're going to have some simple solving like we did in 6.1 with exponents with E. And you're also going to have some continuously compounded interest formulas. It should be pretty simple. But if you have any questions or concerns, please feel free to email me.